Video is for 6.6. We're going to be talking about properties of kites and trapezoids. So first, let's define what each of them are. So a kite, I have a rough picture of one here, but it has exactly two pairs of congruent consecutive sides. Consecutive just means next to each other. So these two sides are congruent and these two sides are congruent, and it's a four-sided quadrilateral, okay? A trapezoid has one pair of parallel bases, so hard to see in that picture, but these are the bases. They're parallel to each other. Sorry, that's a little blurry. So what this says, sorry, I know that's hard to read in the video, that says base angles. Base angles. You guys can probably see it a little better on your packet. So a parallelogram can't be a trapezoid because a parallelogram has two pairs of parallel sides. A trapezoid just has one. And then I drew this in. A midsegment of a trapezoid connects the midpoint to the midpoint of the two legs. So I know it's a midpoint because that piece is congruent to that piece is congruent to that piece. Okay, so we have some properties with respect to the kite and the trapezoid. So here are some of those properties. These are just directly from your book. So if it's a kite, then the diagonals are perpendicular. Remember, that means they're meeting at a right angle. Kites also have one pair of opposite congruent angles, and those angles are actually always where the non-congruent sides join. So in this one, B and D are the same, but A and C are not the same. So we can also have trapezoids that are isosceles. That means the legs are congruent. So in this picture, this leg is congruent to this leg. When that happens, I get two pairs of congruent angles. So A and B are congruent, and angles C and D are congruent. Isosceles trapezoids, sorry, I forgot to write this in, but always have congruent diagonals. So diagonal BD is congruent to diagonal AC. And then the midsegment is always parallel to the two bases, and it's equal to half the sum of the two bases. So there's the formula for that there. We're going to use those in some examples here. Okay, so the first example, we have this kite. They're giving me a few angles. They're telling me angle PQR, so this big angle right there, is 78 degrees. And then they're telling me that TRS is 59. Okay. Sorry, I might zoom in just a hair more so you guys can see those measurements a little bit better. Okay. So we've got 78 and 59. So they want me to find the measure of QRT. So they want me to find this guy right there. So I'm actually just going to call that X. Now, notice these markings here. It is a kite. So a kite, another way to think about a kite, you guys, is actually like two isosceles triangles put together. So this part of the kite is an isosceles triangle. And I know in an isosceles triangle, those two angles must be the same. In this isosceles triangle, these two angles must be the same. So this angle also is 59 degrees. So right now they want me to find what I've labeled X. So also this triangle right here, those three angles must add to 180 per the triangle sum theorem. So I'm going to say 78 plus 2x equals 180. Okay, so subtract 78, so I get 2x equals 102. Divide by 2, and we get x is 51 degrees. So QRT, that angle, is 51 degrees. Okay, QPS. So QPS, well, we just found x is 51, so now QPS is that big angle P. So I'm just going to say angle P, oh, sorry, that's supposed to be a P, not a B. The measure of angle P equals just 51 plus 59. Which is 110 degrees. Okay, PSR, so this is that remaining angle. So something else I can use. There's a couple ways I can do this one. So I know that those two angles are 59. So I could look at this triangle here, this isosceles triangle, and do 59 plus S equals 180. So 59 plus 59... plus measure of angle S equals 180. Sorry, I'm going off the page there. Or another way I could do this all the angles in a quadrilateral must add to 360. So I could also add 110 plus 110 plus 78 plus angle S equals 360. So I'm just going to write that one here. Or 78 plus 110 plus 110 plus measure of angle S equals 360. So either one will get you the solution for angle S, okay? So if we do, I'm just doing that top one, and I'm getting 62. So either way, measure of angle S equals 62, whichever method you want to use. Okay, next we have a trapezoid here. And maybe zoom back out just a little. All right, so we have a trapezoid that has a mid-segment drawn in, and we know it's a mid-segment because of those congruent markings on either side. So remember, the mid-segment, which is n plus 6, is equal to half the two bases added together. So my two bases are n plus 3 and 3n minus 5. Okay, so I'm going to simplify here. So I'm going to combine some like terms, and I'm going to get rid of this fraction. I'm going to multiply by 2. So I'm multiplying this whole side by 2. So 2 times a half is just 1. So I'm left with 1 times what's ever in here, which is 4n, and then 3 minus 5 is negative 2. Over here, multiplying by 2, I've got 2n plus 12. So we've simplified, we've gotten rid of parentheses. Now let's get our n's on the same side. So I'm going to subtract 2n from both sides. So I've got 12 equals 2n minus 2. Add 2 to both sides. And divide by 2 to get n equals 7. And that is all I was asked to find on that problem. Okay. Find the value of x so that PQST is isosceles. So remember, if this trapezoid is isosceles, Q must be congruent to S and P must be congruent to T. So I'm going to set those equal, and that value of X is what would make PQST isosceles. Okay, so I'm going to set 2x squared plus 19 equal to 4x squared minus 13. Okay, so I can see it's got the makings of a quadratic, so I am going to go ahead and set it equal to 0 here. Is that what I want to do? Let's see. Okay, so I've got 19. Sorry, I've got subtract my 2x squared, and I'll subtract 19. So we've got 0 equals, and I'm doing that from both sides, equals 2x squared, and negative 13 minus 19 is 32. Okay, and I am gonna actually solve this using square roots because I don't have a b term here, so sorry, I am gonna add my 32 back. So we've got this. Okay, divide by 2. So I've got 16 equals x squared, and then take the square root. So we've got 4 is equal to x. Technically, it could be positive or negative 4, because if I plug in negative 4 for x squared, negative 4 squared is still 16. And if I were to plug in negative 4 here or here, it would be fine. So I'm going to list both of those as my solutions, that x could be positive or negative 4. Okay, can a trapezoid be a parallelogram? We kind of talked about this. No. A trapezoid can only have one pair of parallel sides, and a parallelogram must have 2 pairs of parallel sides. Okay, that is it for the 6-6 video. Thanks for watching.